Hello everyone and welcome back. Today we're going to continue with trigonometry and we are going to focus on how to find angle measure, or more specifically the acute angle measure in a right triangle when you're given the length of two sides. So before we do that, let's talk about what it means to solve a right triangle, because you're going to hear that throughout. To solve a right triangle means to determine the measures of all six parts. So we want to find the length of three sides and we want to find the angle measures. Now we already know that one angle equals 90 degrees because we're only doing trigonometry in a right triangle. So that means we have to find the measure of the other two acute angles. So we can solve a right triangle if we know two side lengths, or one side length and the measure of one of the acute angles. Before we jump into finding all six parts of information or all six pieces, we need to talk about how we can find the measure of one of the acute angles in a right triangle using the sine, the cosine, and the tangent ratios. So what we are going to introduce today is we are going to introduce inverse trigonometry. So let's talk about that for a moment. Inverse trigonometry is used to find the measure of an acute angle in a right triangle when given the lengths of two sides of the triangle. So let's repeat that. Inverse trig is used to find the measure of an acute angle in a right triangle when given the lengths of two sides of the triangle. And we'll do an example in a few minutes. Now, inverse trig looks a little differently. Let's jump down here to our notation. So here we have triangle ACB, and it's a right triangle with our right angle at vertex C. Notice that this says if the sine of angle A equals x. So that x represents the opposite side divided by the hypotenuse, right? The sine ratio is the opposite divided by the hypotenuse. Then, in order to figure out what the measure of angle A is, we have to take the inverse of that number. So this little sign, this -1 up here, means inverse. And depending on the type of calculator you have, so on this calculator, I know it's difficult to see, but the light blue above here, sine to the -1, cosine to the -1, tangent to the -1. I would have to use the second button to get that sine inverse. Again, I know that's tricky to see. Same thing on the graphing calculator if you're using a graphing calculator. In order to use the sine inverse, the cosine inverse, or the tangent inverse, I would have to use the second button. And notice how I have sine to the -1 up there. So really what we're doing, remember the inverse of anything, addition and subtraction, mathematical inverses, right? Multiplication, division, mathematical inverses. Well, the sine of an angle, when you're given that measure of that angle on one of the sides, will help you find a remaining side. But if I switch those around and take the inverse, if I take that ratio, the opposite side divided by the hypotenuse, then I can find the measure of angle A. So angle A is still this reference angle. I'm still going to need a reference angle. I'm still going to need to identify what the hypotenuse is. I'm still going to identify the adjacent side. I still need to identify the opposite side. But instead of saying the sine of 53 degrees equals x over 42, now we're going to say the sine inverse of x over 42 equals the measure of angle A. So just like in the last lesson where we had to figure out how to use our calculator, we need to do the same thing here. So let's take a look at this first example, and I'm just going to rewrite it off to the side over here. It says the tangent of angle A equals 0.5. So what that really means is that the opposite side divided by the length of the adjacent side equals 0.5. Now I need to figure out what angle is opposite from that. So in order to do that, I need to find the tan inverse of the opposite side divided by the adjacent side, and that's going to equal the measure of angle A. So on my calculator, I have to do the second tangent, or the tangent inverse of 0.5, and look at that. It gives me an angle measure of 26.565 degrees. We'll round it to the nearest tenth. So 26.6 degrees equals the measure of angle A. So these examples actually require a little less math for us. We don't have an equation that we have to solve. We just have to be able to input into our calculator. So let's take a look at example number 3. Example number 3 says the sine of angle A equals 0.35. So what does that mean? That means angle A is my reference angle, and the length of the opposite side divided by the hypotenuse is 0.35 units. Now I want to find the measure of angle A. So in this example, I'm going to do the sine inverse of angle A. Second sine, 0.035. Oops, sorry about that. Second sine, 0.35, there we go. 20.5 degrees equals the measure of angle A. Do I have to go through and write all of this out? No. Is it helpful to write it out? Maybe a little at the beginning, just so you know exactly what it is that you're finding. When you use inverse trigonometry, you are finding the acute angle measure in a right triangle, given the length of two sides. And that's where we'll stop for right now.